Hello, so now we are going to move on to video 2. This is video 2 from Posicast, and in this case we are going to speak about the half-cycle Posicast. So just a recall from elementary notions about second-order systems, this is the general transfer function for a second-order system in the Laplace domain, and we usually call the natural frequency this omega n, and we represent the damping factor with this Greek letter zeta. Also, we are going to represent the overshoot here with delta and the peak time by Tp. These are the important variables by now, so recall these ones. So we are going to consider this model for a second-order system here, and using this expression is quite easy to determine the natural frequency, which in this case is 2 radians per second, and the damping factor, which is 0.35. So as you can see, is an underdamped system. So using this expression, we can evaluate the overshoot, which is 0.31. From this expression, we evaluate the amplitude of the first step, 0.764. The second one can be obtained by this one, 0.236. And the transition time is 1.68. So using the same representation as the last video, the amplitude A1 is this one, the amplitude A2 is this one, and this adds to 1 as should be, and the transition time or delay time for the second step is this one. Okay, so a block diagram representation can be this one, where this is A1, this is A2, the step should be 1, amplitude 1, and the delay is this one. Okay, the system is the model, and we are going to represent simulate this using Simulink. So this is the model. I just am going to explain you what are the settings. The settings for the first step is the step time is 0, the initial time is 0, and the final time is 1. The delay is 1.68, should put here. And the transfer function, you just have to put the numerator vector and the denominator for the transfer function. And very important, change the solver from the solver selection from variable step to fixed step. And we are going to use a fixed step size of 0.01 seconds. 01, this one. So we have a nice resolution. So if we run, this is the outcome of you can see the scope. So we see is a perfect response without overshoot. So the simulation, the half-cycle Posicast works very well. So if you change now the number of ports to 4 in this part here, so play here, so press this point, you got to change this to 4, use this layout to see the 4 graphs. And if you connect to the first port, the reference signal, this is the first port. The second port represents U1, this is the second port. The third port represents U2, is this the third port, and the final port is Dubai. So we can see here what happens. So this is like the first step is 1, as you can see here. The second step, so this is the reference. This is U1, is like the amplitude is this one. Then you got the U2, and not the band, and you got here the delay time. This is 1.68, and we got the output here, which is a nice response without overshoot. Okay, with this I conclude the video 2, and I thank you for watching.